Hello students, in this module we will see the Cox proportional hazard modeling using R. The first paper on Cox proportional hazard modeling written by Sir David Cox 1972, and there are so many packages nowadays available in different software, and in R we will illustrate the application of Cox proportional hazard modeling on example data set. In Cox proportional hazard modeling, the basic assumption is that both arms are having equal hazard ratio over the period, that is study period. In earlier module we have seen the application of Kaplan-Meier estimation and log-rank test, where these statistical tools are applicable to compare the curves and estimate the survival duration for patients. But when we are having variable of interest that playing role on the survival of the patient, like age, sex and other prognostic factor, then it plays important role to consider those variable, that is covariates, on their hazard function. So, Cox proportional hazard is having beauty to consider these covariates to accumulate and thereafter to get the estimation about hazard ratio. Those factor multiply consider to estimate the hazard ratio. We have seen that module the mathematical expression of Cox proportional hazard, where we one hand we take the ratio of two arm and in another hand we take the exponential form of covariates, and we measure the effect of factor towards hazard ratio. The basic assumption in Cox proportional hazard model is that between the two arms the hazard ratio should be maintained as same value. So, diagnostic of Cox proportional hazard modeling is one part that we will see in later module, but as well in this module we will see the application of Cox modeling through consideration of different prognostic factor in a example data. The basic objective of this module is exploring R to get statistical inference through Cox proportional hazard modeling and make the statistical inference from the result part. End of this module we will learn how to get Cox proportional partial likelihood estimation using R, how to get stratified Cox proportional model through R, and obviously we will go through this model with drug treatment effect comparison. Let us come to the data. This is survival data taken from Edmondson 1979 paper on ovarian cancer data. First variable is FU time is taken from this data set, is basically the survival or censoring time observed for each individuals. Now the FU censoring status of those patients given as 1 and 2, if they censored given as 1, if they not censored then given as 2. Now the age in years of each patient considered here. Now res.ds residual disease presence or not given as, if they are having residual disease then it is given as 2. and 1 for no. So numerically presence is given higher marks in the coding time, and the Rx of treatment groups also given here as 1 and 2. Now we are going for performance score, that is given as ECOG. It is noted that if ECOG is better, the 1, then patients are having good performance indices, and here two values are considered for ECOG, that is 1 and 2. Now we will apply the Cox proportional model through target effect comparison, as well we will see how to get the partial likelihood estimation and stratified Cox proportional regression model. Here we are calling the library survival, and into that we are calling the data ovarian, and once we put the data ovarian, and to show that first 5 individuals data, we are calling ovarian, and for 1 to 5 comma, it will give us the 5 individuals informations of all variables. And in the next slide we will see the R output. This is the R output for FU time for first individual 59, second individual 115 days, third individual 156 days, fourth individual 421 days, and fifth individual 431 days, and their status is given as 1 and 0. If they censor, then it is given as 1, if they not censor, given as 0, and corresponding their age is given as like 72.33 years for first individual who entered in the study, 74.49 years for the second individual who entered in the study, and corresponding their residual.ds also given, 2 is given for there. And again if you see the column with Rx, it's given as 1 and 2, so it says that what is the treatment given to them, it's Rx1 and Rx2. So I like to see the details about the treatment effect and their literature in this main article to get the details idea about the treatment. Now we are going for ECOG again, this performance code again given as 1 and 2. Now we are directly going for this application part. This is the function used here in R to get the Cox proportional regression model. Its function is called COXPH, that is useful, and since we are having two variables that we mentioned earlier slide, that is FU time and FU stat, so these are considered into the parenthesis with function SURV, and these both the functions COXPH and SURV is only applicable in the library called survival. And now we are trying to find out what is the treatment effect difference between these two groups through Cox proportional hazard modeling, and we are putting, that's why we are putting the trial Rx there, and Rx is there 1 and 2. Again we are also putting another factor that is considered as the age factor. So how this age also contributing towards the death or alive of the patients, that has considered as age. So we consider age as a factor here, and comma, and the ovarian, that is we are having the data set as ovarian, and after putting this thing, that is whole functions command is assigned to a space that is called CPH1, and again we are calling the CPH1 as summary within parenthesis CPH1, we will get the Cox proportional estimations. Now we are going to next slide to get the Cox proportional result. This is the R output. If you run the earlier program into R editor, then in R console you will get this result, that is given with first line will give you the Cox page and formula as sum of FU time and FU status with Rx and age that you have considered here. Here we are having total number of observation, that is 26, that is given by n equals to small n equals to 26, with number of events that are also giving as a 12. So it's primarily basic statistics given, how many patient died, that is given as number of 12 out of 26 patients. Now we are applying this Cox proportional hazard model, and we are with our two factors, that is Rx and age, and the coefficients of Rx is coming as a minus 0.80397, and for age is coming plus 0.14733. Here it is better to consider exponential of coefficient than only coefficient value, because this exponential of coefficients gives us the automatically the odds ratio value for specifically for that factor. So exponential of coefficients for Rx is coming 0.44 with standard error of coefficients 0.63. So if we add the standard error of coefficients with exponential of coefficients, then we will get the 95% confidence interval, and minus subtraction will also give us the lower confidence interval. Correspondingly, if we go the last column part of this result, that is coming by the Z statistics, Z test value, that is before the last column, that is given as Z. So we will see the p value is coming as the last column, that is 0.20337 for Rx and 0.001441 for age. So the p value says that age is having significance influence on the status of these patients. So here again the third below the age coefficients estimations, we are getting the significance code as 0 is triple star, 0.001 as double star, like that. So here we can get the which probability or p value should be considered with 95% or 99% or 90%. So if we consider with 95%, in that case age is having really influencing factor on status of this patient, that is event of these patients. Not only that, the coefficients that we had mentioned earlier, the standard error of coefficients in addition with exponential of coefficients can give us a 95% confidence interval, but if you see the below line is also giving the lower 0.95 and upper 0.95 confidence interval for both the factor Rx and age. For Rx is coming with confidence interval 0.1297 with upper confidence interval 1.545, and for age the lower confidence interval of this estimate, that is 1.15, it's coming 1.05 to 1.26. So here it is to be noted that since the exponential of coefficients for age is coming 1.15, it states that in comparison to one group, another group having, those are having age higher, they are having more event rate. And since the odds ratio, since the coefficients value, it can be considered definitely as a odds ratio, and since this confidence interval of these estimates, that is exponential of coefficients coming between 1.05 to 1.26, we can easily state that the confidence interval is in the higher side, more than 1, and definitely as a result we have found that p value is significant. Here the log like based also there, it says that how model is fitted here, it shows that model fitting positions, wall test value also will get. In both cases we are getting that both where p value has significance. So here we may consider this is a suitable fitted model in this scenario. The proportional hazard model is usually expressed in terms of a single survival time value for each persons with possible censoring. The paper of Anderson and Gale reformulated the same problem as a counting process. As time marches onwards, we observe the event for a subject rather like watching a Geiger counter. The data for a subject is presented as a multiple row or observation, each of which applied to interval or observations from startup to stop periods. Now we will go to next slide. Now this is the questions about the interpretations. If a patient is treated with Rx1 and age is 50, what will be his hazard ratio in comparison to the patients who treated with Rx2 and whose age is 60. So this is the question, what if we have wanted to estimate about that. The point estimate is easily obtained as exponential of minus 0.804 with 1 minus 2, that is 1 represent the Rx1 minus Rx2, that is coded in this data set, plus 0.147, that is estimates obtained for age with multiplied with 50 minus 60, that is age of these individuals, first individual minus age of this 60 second individual, that is age 60. So see why we are multiplying 0.147 with age of 50 minus 60, and why that can be seen in earlier state, that we got estimate of age as 0.1577. So seeing estimates of coefficients for age is coming 0.1477733. Here we are, that's why we are multiplying 1.7 with 50 minus 60 age groups. Again we are multiplying minus 0.80 with 1 minus 2, that is 1 is standing for Rx1 and 2 is standing for Rx2, and again minus 0.84 because coefficients of age is Rx is coming here minus 0.80397, so we have considered it's minus 0.804. Now we will come. So this way you can interpret the value that point estimate is easily obtained, that 0.141. So the hazard rate for individuals who is having age 50 years with treated with treatment 1 Rx1, the hazard of that person in comparison to person who treated with 2 and age 60 is 0.154, that is having 50% chance of being died, that is given by this interpretation. Now we are coming for the with the log life value. For we are having, since we are having two treatment group, that is given as Rx1 and Rx2, so here we are putting the Coxs PBS serve of FU time and FU stat follows to Rx. You can remind that in earlier modules we had put the serve fit, and within parentheses we put the serve and FU time and FU stat. Here we are replace the serve fit as a Coxs pH. So if you put the serve fit, it will give us the by default the Kaplan-Meier estimate, but in place of serve fit, if we put here Coxs pH, it will give us the Coxs proportional hazard modeling with the same data set over here. Now again this whole function set is assigned to a measure called CPH1R. Now if you put the CPH1R as tick block live, it will give the range of this likelihood minus 34.98494 to minus 27.04190. So it gives the two treatment, that is Rx1 and Rx2's log likelihood value. The obviously log likelihood value must be less than 0, it must be in 0, must be negative value, but as the value keep on increase near to 0, comes near to 0, it's best fitted suitable for this specific model. Here it's also the same thing. Now I will go for, and this is the partial likelihood estimation for Coxs proportional regression modeling. Now we will go for stratified. Now we will go for stratified Coxs proportional regression modeling. Stratified Coxs proportional regression modeling can be done with strata. Here we have considered the strata, that is age more than 25 years, and for only selected case, those are patients those are having age more than 25 years, they have considered in this analysis in comparison to those are having age less than 25, less than or equal to age 25. So this is the functions to run with stratified Coxs proportional modeling, and this measure we are assigning as CPH2, where again equals to considered as Coxs pH functions, and within parentheses serve, FU time and FU stat is considered, follows to Rx and strata. So this is the thing, and we are running the Coxs pH, we will get the result. Let's see the results output. This is the results. Say earlier stage we had considered the Rx and age, but in this case we didn't consider the Rx and age, we had considered only one strata, that is having age more than 25. So these value will only give the interpretation coefficients estimates for Rx, that is minus 0.49 with exponentials of coefficients, that is 0.55, having standard error 0.587, having p value 0.31. Here the likelihood ratio test having value 1.05 with significance p value significance value with 0.305. Again the number of events observed with 12, having total observations 26. So earlier earlier we are having only consider the age, but here we divided the age into two part, one part with age more than 25, another one with less than 25. Within that strata we had considered the run. So here as a estimate value for age regression coefficient, we will not get any value, only regression coefficient value of Rx will come here, that we can see here, and it says that there is not any significant difference in terms of treatment between these two arms on survival duration of the patients. Now we will go for third kind of modeling with Cox proportional hazard additive modeling, where the CpH3 is considered measured as a Cox pH of sub-effuse time and effuse state Rx of age greater than 50 and over here, and it's assigned as summary Cox pH3, and then we will see the result in next slide. Say earlier we have considered only the basic difference between this model and earlier model is that we didn't consider the adhesive part into the earlier model. We have only considered the strata part, but here we are considering the adhesive part with condition with those patients having age more than 50 years. This is the result. Here we are getting the estimate regression coefficients estimates for 50 years plus patients, those, and for that it is getting it is coming with 2.2035 regression coefficients for those having age more than 50 years, with odds value that is 9.0567, having probability having p value with 0.0422. It shows that yes, age is having significance influence on the status of this patient, that is on event of these patients, and definitely is positively influencing. So if the age increases, definitely number of patients will die, that also increases. Here Waltz test is giving 6.65 value, log likelihood ratio test coming with 7.52 value, with degree of freedom 2, having p value for likelihood ratio test is 0.02331, Waltz test is 6.6 value with 2 degree of freedom and p value 0.0359, and score for log rank test is coming 7.42 with 2 degree of freedom and p value 0.024. So it's giving us the complete result as well as the confidence interval with also coming for odds, that is coming 1.08 for age greater than 50 years to 74 5.86 to 06. So it shows that it's quite wide range, definitely, because point estimate for age is only 9.05 as odds of age is 9.05 and lower confidence rate 1.08 to 7.86. It's happened since we had categorized our whole patient, that is only 26 again into two part, that is only for a patient having a 50 years. So we got less number of patients, and based on the less number of patients the estimate will be quite fluctuated. So that's why we are getting the odds ratio for age with 9.052 with confidence interval 1.08 to 75.86. Now we will go for interaction model with Cox proportional hazard functions. Again, in earlier case we had considered only adhesive case. Now we are considering these Rx multiplied with age, those are having a greater than 60 years, and as a result we are getting three values, that is Rx age greater than 60 years and interaction effect of Rx and age, those are having 60 years plus. So since here the reference group is considered as 2, so reference group considers 2 and Rx is coded as 1 and 2, so numerically the lesser value of Rx will be considered as the reference group. So with reference to first group, what is happening into the second groups, that is given as Rx minus 0.35 and its exponential of coefficients coming with 0.705 with standard error of coefficient coming 0.81 and with p value 0.67, and the for case of factor age, those are having age more than 60 years is coming 2.01 with exponential of coefficient exponential of value 7.47 and p value 0.28, where the interaction value between Rx2 and age now the patients are having age Rx2 and those are having age more than 60 years, the interaction value coming with 0.017 with odds with 1.19. It shows that also it's not significantly influencing the death status of the patients. However, as a whole model can be considered a significant model since the log like test p value coming 0.00821 with n equals to 26 and number of event as 12, and this corresponding log live test is coming 11.8 with 3 degree of freedom. So, this is the example from how to we can generate the adhesive model. The application of Cox proportional hazard model is widely adopted since last few years. In this module, we have seen how to apply Cox proportional hazard model using R on a sample data set. We have seen the application of function called Cox pH to get the partial likelihood estimation on Cox proportional hazard modeling. We have also seen how to interpret the result part from Cox proportional hazard modeling. We have seen the how to perform stratified Cox proportional hazard modeling using R when we are having variable and those variable can be stratified into 2 or more than group, then stratified Cox proportional hazard can be used, that we have seen. We are also illustrated in this module how to compare drug treatment effect through application of Cox proportional hazard modeling. Here we have also seen how to get the prognostic score for a single patient based on the earlier studies Cox proportional hazard modeling inference.